Hello, this is question 4 on your AQA June 2024 AES paper. It's a trigonometric question, and we have to find a suitable trigonometric identity to show that this equation can be written this way. This is very simple, it's just one mark, and if you remember that tan is sine divided by cos, it's quite straightforward. So we are going to substitute the tan by sine divided by cos, and then we have in this side sine times sine is sine squared, and we can put this cos dividing here, that together with this cos is cos squared. So we have sine squared divided by cos squared is 4, which means tan squared is going to be equal to 4. Yeah, just that. Then for the second part, it said, hence, we are going to use this, solve this equation, which means instead of solving this equation, we are going to solve this one because it's simpler, yeah, and they are the same. So tan squared equals to 4 means that tan, doing the square root, is going to be plus or minus 2. So we have like two branches of solutions, if you want to think that way. One when tan is 2, and then when tan is minus 2. Calculator. If we do tan minus 1 of 2 in degrees, we get that theta is 63.43 something else. Yeah. In a minute I'm going to round, but I'm going to find first all the solutions. Then remember that tan repeats every 180 degrees. So the next solution is going to be when I add 180 here, which is 243.43. And if I add 180, I am out of the interval. Yeah. So this tan equals to 2 gives me two solutions. Now, if I do the same with tan minus 1 of minus 2, I get with the calculator minus 63.43, which is not in my interval, but it still is going to help me to find the other solutions. So again, because tan repeats every 180, I add 180 and I get one solution that is in the interval, which is this one, and another solution adding again 180, which is 297. Yeah, 297. And these are my solutions. This one is not in my interval, so I'm just going to write them all together, rounded to nearest degree. Yeah, they tell me what to round to. So 63, 117, 243, and 297. And these are my four solutions. Yeah, if I add 180 here, it will be out of the interval. Yeah, so for next part, they say deduce all the solutions of this equation. So they are not asking me to solve the equation, they are asking me to deduce the solutions, because if you look at this equation, it's like this one, but where I have theta, now I have 3 alpha, and I need to find alpha. So what I'm going to do is to use the solutions for alpha from the previous question. So when theta is 63 point, and I'm going to keep the decimals, because I'm going to divide by 3, and maybe if I round too early, I don't get the same answer. Yeah, so when you have to use rounded answers, be careful. If possible, use the original one. So this is 3 alpha. That means that alpha is that divided by 3, which is 21 rounded to the nearest degree. When theta is 117.43, this is 3 alpha. Alpha is 39 degrees. When theta is 243.43, alpha is that divided by 3, so 81 degrees. And when theta is 297.43, I get alpha 99. But if you notice, our interval goes up to 180, and this is only 99. And they go quite close to each other, the answers, so it's very likely that we have more answers. How are we going to find them? We are going to find them doing finding the next answers here. Yeah. Next answer will be when I add 180. Yeah, that would be 423.43. If this is equal to 3 alpha, I still get an alpha in my interval, which is 141. And if I do the same, again, I get 477.43, which again is in my interval. If I do it again, this one is not going to be in my interval. Yeah, it's above 180. So I'm going to stop here. So these are my answers for alpha. Yeah, and remember to use the numbers without rounding. Yeah, or at least a couple of decimals, because then you're going to round to the nearest degree again. Yeah, and that's all with this question.